Today we are going to talk about light. Specifically, we have three things that you need to know about light. There are certain types of light. They can be absorbed, light can be emitted, or it can be reflected. So we want to just kind of go over those really quickly. If you think of a stage, if you go, for example, to our stage at Hidden Valley, all right, you will notice that that in the back and on the sides there are black curtains, all right, and these absorb light. Solar panels on the roof of a house or on the roof of a building would absorb energy. And have you ever gotten into a car when it's been sitting in the sun? If you happen to have black seats in your car, they absorb the heat, and they're so hot you can't even sit in them. Right? That's an example of something that is absorbing light. Now, light can be emitted. The sun emits light. Light bulbs emit light. And stars emit light. So if you go out at night, you can see stars. They are giving up light. They are emitting light. Now, I have to be very careful because we say, well, the moon is bright at night, but the moon is not emitting light. It's reflecting light. It's getting light from the sun. Saturn, similarly, is a planet, right? It is reflecting the sun's light, right? Now, why have I got a tree up here and a classroom up here? What have those got to do with anything? Well, think about it. At night, can you see the tree? If it's overcast and there's no light, all right, now granted, in Roanoke, you're going to see a tree, or you're going to see somewhat of a tree, not terribly well, because there's so much ambient light from street lights and cars and the city itself. But go to someplace like the top of a mountain, all right, like McAfee's Knob, for example, and I expect it's a lot darker up there, and at 2 in the morning, and you will not be able to see a tree, all right, unless the moon is out. And again, it's reflecting the sun's light, right? If you take a classroom and you turn out all the lights, it goes dark. You can't see what's across the room from you, right? Everything in the classroom is reflecting the sun's light, or the light that's being emitted from these lights up here, right? So that's all reflected light. Now, in addition to absorbed light, emitted light, and reflected light, we also need to understand, and you should understand from earth science, because you did cover this, that the sun gives off a full spectrum of light. So does an incandescent light bulb. It's the one that gets hot, right? So the sun puts off all frequencies of light, and as a result, you can see a rainbow. Or we can take an incandescent light and put the light through a prism, and it will give us a full spectrum of light. But we also have the concept of line spectra, and again, you discussed this in earth science, right? Line spectra is the concept of you have a particular light. In this case, what we have is we have some hydrogen gas inside a tube. And we heat that up, and it gives off a light. Now, in this case, it kind of looks like it's pink or purple. And the reason it looks like it's kind of pink or purple is because hydrogen does not give off like the sun gives off. The sun gives off all frequencies of light. But hydrogen does not. Hydrogen only gives off 5 visible frequencies of light. All right? And the red one and the blue one and a couple of purple ones and a very dark blue one. All right? So as a result, when you put those 5 together, what you see is kind of this hot pink or purplish light. Right? Because these are the only colors that hydrogen actually puts off. And if you put it through a prism, then you see these 5 lines down here, down at the bottom. In these lines down here, you're going to see those 5 lines, right, if you look at the light from hydrogen through a prism. So it gives off these 5 colors of light. So what happens if we take hydrogen gas and we put light through it? We shine sunlight on the hydrogen gas. What's going to happen is the hydrogen gas is going to absorb those same frequencies of light that it would have given off if it were heated. But since the hydrogen gas is cold and it is absorbing energy, it is going to absorb those exact 5 lines, those 5 frequencies of light. So you, again, if you would look at it through a prism, you'd actually see essentially voids there where that light was being absorbed. All right, this stuff is back from Earth Science. Again, if you've got problems with it, don't understand it, please come see me. All right, it's not new. So what do you need to know? You need to know that light can be absorbed, emitted, or reflected. You need to understand where a complete spectrum of light, visible light, comes from and what it looks like. It looks like a rainbow. Where does it come from? The sun and incandescent light. Those are examples. Right? You need to understand the concept of line spectra and where they come from. They are caused by stuff like a single element when it is heated up. All right? And its opposite. Its opposite is when a gas would absorb it. That's an absorption spectra. Okay? Again, if you have questions about this, please come see me. I'm happy to help. There is a worksheet that you need to do just to try and get this stuff fully ingrained in your head. Right? And when you're done, you can come to class and take your test. I'll see you there. Have a great day.